In this example, we see that return loss failed with a margin of minus 1.7 dB. And on this occasion it's caused by a cable issue. And in your DTX cable analyzer, it has the ability to determine if that is indeed a cable issue and maybe where that's happening in the cabling system. As with all return loss failures, the first thing that we actually want to do is go and look at resistance. We have our 4 pairs here. They're all slightly different because of the different twist rates within the cable, and we want to make sure that they're all roughly the same. And they are. If you see a difference of 2 or 3 ohms between the pairs, then we know we have a DC contact resistance issue. Okay, no issue going on here. Exit, and we'll go back down to return loss. And as just before, we're looking to see which pair failed the worst. So we hit the enter key. Oh my, have a look at this trace. We can see that everything is above the limit line, this nice smooth line here, and everything is above it with some good margin, or what people call headroom. But this, just at this one point here, it dips straight through the limit line and comes straight back up. Let's press the F3 key to find out which pair that was. And on this occasion it's pair 1, 2. That's a cable fault. If you ever look at a frequency plot like this and it looks fine but you only see a single source of failure, it goes straight down and comes back up, it's a cable issue. Now normally in most other testers that's about as far as you can go. We can go a little bit deeper in this tester. I'm going to hit the exit key and again, and I'm going to go down to my HD TDR analyzer, my high definition time domain reflectometer. This is going to allow me to look down the cable and see where the anomalies are that are causing this return loss failure. So I'm going to hit the enter key, and then I'm going to hit the F2 key to get to that pair 1, 2. Now, just as before, we hardly see anything on here, and as with the HD TDR, we press the F2 key zoom and then the up arrow key until we see 64X appear in the top right hand corner. Remember our rule from the previous modules? We don't want more than 0.8% in the cable or minus 0.8% in the cable, which is roughly halfway up the scale here. Let's put in those 0.8 and minus 0.8 lines now. We're going to put them in here and here. And we can see that pretty much all the way down the cable it's exceeded our 0.8 and minus 0.8%. Sure, you're going to get a couple which exceeded, that's normal, but look at how many in the density of what's going on. We definitely have a cable issue here. Now there is a short area here where it's not too bad, but for the best part this is happening all the way down the cable, and it's only happening on one pair. Now experience tells us that if it's only happening on one pair and it's happening all the way down the cable, the installer is off the hook this time. Unfortunately it's the cable manufacturer. They had some bad cable escaped out the factory. It happens. Frankly, it's not that frequent, but it does happen, and it's exactly the reason why you have to certify a cabling system. So on this occasion here, we'll save our test result and we can send it to the manufacturer and say, hey, based on the HD TDR data and also that frequency domain data, you have unfortunately delivered us some bad cable.